Okay, so in this video we're going to have a look at an inequalities proof by induction. So same set of 3 steps as always. Our first step, we're going to prove true. Now just be careful here, it's n greater than or equal to 2. So instead of n equals 1, our first step will be n equals 2. So we get 3 to the power 2 will be greater than 2 squared. So that's 9 is greater than 4. So we're true for n equals 2. Then step 2, we'll assume true for n equals k. We'll have 3 to the power k is going to be greater than k squared. Okay, we'll leave that one there, but we'll come back to it in step 3. And now we prove true for n equals k plus 1. So that gives me 3 to the power k plus 1 will be greater than k plus 1 squared. Multiply out 3 to the power k by 3 be greater than, this bracket will give us k squared plus 2k plus 1. Okay, so this is where step 2 comes back into play. And just maybe a little bit of manipulation first. So this 3, I'm going to split it into 2 plus 1. So I'll have 3 to the power of k by 2 plus 1 is greater than k squared plus 2k plus 1. And now I can multiply out these two. So 2 times 3 to the power k plus 1 times 3 to the power k be greater than, right hand side stays the same. Again, just 2 by, I'm oversimplifying my steps, but it'll just make the solution a bit more obvious for now. Once you're comfortable with this proof, or this approach at least, there's no need to have this level of detail. So we have 3 to the power k is greater than k squared. So that's there and there. And then it means what we're left over with is this. So we're just going to double check. And as they told us at the start, n is greater than or equal to 2, we'll verify it for 2. And if it holds true for 2, then the same can be said of 3, 4, 5, and so on. So we have 2 by 3k, 3 to the power k has to be greater than 2k plus 1. So that's, so we got 2 times 9 will be greater than 4 plus 1. 2 9s are 18 is greater than 5. So just there I've shown that it's true for k is greater than or equal to 2. And again, that came from their step at the start, or condition, sorry, where they said n is greater than or equal to 2. Okay. And our last statement for step 3, we're going to say therefore true for n equals k plus 1. Just what happened here was we had 3 to the power k is greater than k squared from step 2. And our final statement, we have 3 to the power of n is greater than n squared is true for n greater than or equal to 2 and n an element of n. Okay, so there's your proof by induction for an inequalities proof, and that's us done.